MAT1033 Final Exam Review Question 22, Absolute Value Equation. I have the absolute value of x plus 4 is equal to 10. Okay, so as we learned in class, we need the absolute value portion of the equation isolated on one side, which it is, and we're looking for a value of x that would make this true. So if we could find what value of x would make this either 10 or negative 10, then when we take the absolute value, we would end up with 10. So we are going to have the two possible equations, x plus 4 equals 10, or we would have x plus 4 equals negative 10. And then we solve these two linear equations, x equals 6, x equals negative 14, and that should give us the two solutions for the original equation, negative 14, 6. Okay, now, anytime you solve any equation, you should check it. Now, I haven't been checking them for you, but I am going to check x equals negative 14 to show you that it does make the absolute value equation true. So I'm going to plug in the negative 14, add 4, and then that's the absolute value of negative 10, which does equal 10, so that checks, and you can check the other one. MAT1033 Final Exam Review Question number 23. We are to solve by completing the square. We have a quadratic equation, x squared minus 5x plus 1 equals 0. Okay, now in completing the square, we've got a 5 or 6 step process. It's already in standard form. Let's identify A. A is 1, it's the lead coefficient, and then B is equal to negative 5, and C is equal to 1. Then we're going to move the constant, so we want to subtract 1 from both sides in order to isolate the x squared and the x term, and we'll end up with x squared minus 5x equals negative 1. And to complete the square, we would add 1/2 times b over a. b is negative 5, a is 1. So 1/2 of negative 5 over 1 squared. We're going to add that value to both sides of the equation. Oops. Let me rewrite that here. Okay. Negative 5 over 1 quantity squared. Okay. Now, half of negative 5 is negative 5 over 2, and when you square that, you get 25 over 4. So that is going to be the value that we add to both sides. X squared minus 5x plus 25 over 4 is the number we are going to add to both sides, and that's the addition property of equality that allows us to do that and still have an equivalent equation to what we started with. Remember, we're completing the square, so once we get the trinomial, it should factor into two binomials that are identical to each other. So we've got x and x, and then what times itself gives you 25 fourths? Well, that would be the 5 halves. And remember our work with factoring, they would both have to be subtraction in order to multiply them to get a positive and add them to get a negative. And then on the right hand side, we need to get a common denominator, which would that's over 1, so we would multiply top and bottom of this by 4. So we've got negative 4 plus 25. So on the right hand side, we end up with 21 over 4. Okay, rewriting the left hand side as a binomial squared equals 21 over 4. Now we can take the square root of both sides. So we have x minus 5 over 2 equals, don't forget we have two values when you take the even index root of a number. And then we're going to add the 5 halves, and we put it in front of the plus or minus. And remember, we don't leave a radical with a fraction for a radicand. So right now we have 5 over 2 minus, using our quotient rule, square root of 21 over square root of 4 is 2, and we would have 5 halves plus, same thing, split this up by the quotient rule, give the top its own symbol, give the bottom its own symbol. Square root of 4 is 2. 21 doesn't have any perfect square factors, so these are the simplest forms of the answers.